Hi everyone, welcome to Vedantu JEE English. I am Diksha Kaushal, your chemistry master teacher. And students, this is the third part of isomerism and today we are going to complete isomerism. But before that, there is a good news guys, and what is it? Yes everybody, can you see that over there that we are 300k right now? And this is only possible because of you guys, because of your love, right? And this is the reason that we are here, right? Because when we see students appreciating us, that gives us motivation to do more for you, right? It's not easy, right, to sacrifice our personal life and take your classes like maybe at 8, 9 p.m, 10 p.m. Sometimes our classes are going till 11 or 12 also, right? And right now you are still 2-3 months away from the exam. Still you can see the consistency in our sessions. If we have promised that daily you will have 6 p.m, 8 p.m. classes, without any fail you have those classes, right? So pure consistency and your support and your consistency as well has led to this particular time here. And thank you so much everyone for all your love and blessings. And now let's make it 400k soon. For that, what you have to do, share this with your friends, right? Because don't think that, oh my god, they will get some good content. Don't think about that. Sharing is caring, right? When you give something to someone, right, someone is watching out there, right? You will definitely get it in return, right? If you're helping someone, someone will help you, right? This universe is like that only. But for that, you have to be very kind. Share this with your friends. Share our sessions on Instagram if you're on that. Share our sessions on WhatsApp status, right? Show the love, right? And share this. And I see that very few students who write down in the comment section and very few students who like the session, right? So like this session so that we can spread this particular educational platform to like throughout India, right? Because India has so many languages, right? So this is the beauty of India. India is diverse, right? But the beauty is that if we are united, right, then we can do anything, right? For that, what you have to do, right? This is a language, right? There is no language barrier when we are speaking in English, right? Be it any regional language, right? At this point, the year that we are living in 2025, English is like common in all the schools, right? And that's why it's very important for you to share this with your friends so that even those students who are not able to get good content in their own regional language, right, they can pursue this channel, right? They can have this channel where in English we are teaching, right? And very easy English we are teaching, right? Things are more understandable here, right? Okay, yes. And guys, MVSAT scholarship program, I hope so. Tell me one thing in the comment section, in the chat box. How many of you have registered yourself, right? Let me see in the chat box how many of you have registered yourself to the MVSAT scholarship program, right? Because this program, without even charging you a single penny, right, what we are providing you is 100% scholarship, right? And we are providing you 150 crore worth of scholarship and 2 crore worth of prizes and cash, right? These are not easy things to gain, right? Not easy. You're going to save your parents money. It's a big thing. At your age, it's a big thing, right? So save that. What you need to do, just register yourself. You're already studying daily. If you're coming to my sessions, that means you have good knowledge, right? So be a part of this program. Not even a single penny we are charging you. This is for your benefit only, right? That's why on daily basis I am saying register yourself. This is a one-time opportunity. You are not going to get it again, right? It's not only these things. We are providing you one-on-one counseling, everything. But for that you have to appear for the test on 4th, 5th, 11th and 12th, any of these days. These are Saturdays, Sundays only, and 45 questions will be there, physics, chemistry and mathematics, right, for your JEE, right? Okay, yes everybody, so I hope so you guys have registered yourself because these opportunities don't come again and again. I wish I had this opportunity when I was of your age, right? But at that point, very rare scholarship programs, even the online were very less, right? So if you're not that greedy of iPads, iPhone, you can, send it to my home. Like, firstly, have it for free, and then you can just give it to me, right? Have that, right? It will make your life very easy, and you'll feel so proud of yourself that you have earned it yourself, right? This is our reward to you, right? Okay, yes, everybody. Yes, very good, very good, very good. Hi, Sumrita, Rama, Raju, Bhardwaj, 12 people watched this lecture. It's part of organic chemistry. I'm a little weak. Yes, definitely, Bhardwaj, you should watch this lecture, because if organic chemistry of class 11th is weak, automatically of class 12th, even if you cram the formulas, I'm saying, even if you cram the organic reactions, okay, this gives rise to this gives rise to this. First thing is, mechanisms will be a big deal for you if your GOC is not like smooth, right? Mechanisms are based on GOC, right? Second thing is, even in the mechanism, the intermediates that you have, right, that will be defined by GOC. In isomerism, today what we are going to do, conformers of alkane, RS, DL configuration, these are directly asked to you. We'll see what kind of questions they ask you. And isomerism is a very important part that usually students take it very lightly, but it's a very important part, right? Okay, so guys, in the first lecture, those who have not watched it, guys, please watch after this lecture, go and watch this lecture as well. In the first, we know that isomerism is divided into two parts: structural, that is also called as constitutional isomerism. These all we discussed in the first part. Now then there is stereoisomerism. That means the arrangement in 3D space is different, right? For example, me, right? I can't be like that, okay, my head is paining, let me remove that and keep it somewhere else. Oh my god, my arm is paining a lot, my shoulder is paining a lot, let me remove it and put it somewhere else. I can't do that, right? So linkages I can't change. In structure, you can change the linkages. In stereo, you can change the 3D arrangement. I can do this, I can do this, I can do this, right? But I can't just rotate it and put it somewhere else, right? We can't do that, right? Only in operation we can do that, right? So stereoisomers are in 3D the arrangement, right? Now these are further divided into two parts. One is configurational, where in the last lecture, lecture number 2, we discussed about geometrical and optical isomerism in detail. We discussed about cis-trans, EZ, anti-syn. Here we discussed about chirality, optical activity in allenes, in spiro compounds, in biphenyls, everything we discussed. We also discussed about how to calculate geometrical isomerism, how to calculate optical isomers, how to calculate total stereo isomers, right? These all we have done. So today's part is going to be the extension of this, which is RS and DL configuration, which is very smooth, easy. It is based on CIP rule that we discussed in the last class. Then conformational isomers, and the last part of today's lecture is going to be DU. That is not Delhi University. It is a degree of unsaturation, right? Based on degree of unsaturation, this question is also very important. Calculate, they will give you some formula. Let's say they have given you formula C8H12. Now calculate how many isomers are possible for it, right? So sometimes 15 isomers, 10 isomers are possible. You can't if you don't know how to solve the DU, then you will be stuck there in solving one and then second. You will take 10 minutes to solve one question. We don't have enough time. That's why we'll understand how to solve degree of unsaturation, and from that degree of unsaturation, how you are going to solve the isomers, right? Okay, everybody, and today it will be done and dusted. So let us start here with RS configuration, right? So RS configuration is based on CIP rule that we discussed in EZ configuration as well. So RS configuration, firstly we'll understand, then we'll understand how from RS we can define optical activity, whether they are distereomers or they are enantiomers. These things we will discuss, right? And about enantiomer, distereomers, you have all these things in haloalkanes, haloarenes as well. So instead of repeating that again, I am doing it here today, right? Because the basics I'll do today, some part of it that is applied in haloalkanes, halorines, I'll do that in your that chapter, right? So first is CIP, Carl, Ingold and Pre-Rog rule is that highest atomic number, you are going to define the priority here. So there are priority will be, highest priority means highest priority will be 1 and lowest priority will be 4, right? So on one carbon you will have 4, because see, when we were discussing EZ, we were discussing about geometrical isomers. So that's why we wanted to know the priority on this and this. Then we wanted to know the priority on this and this. That's how we defined E and Z. In this case, we want to check one single carbon according to its chirality, right? That is the reason you will have one carbon that will have 4 different groups, right? One carbon having 4 different groups, that means it is a chiral carbon, right? So when you have a chiral carbon, what is a chiral carbon, everyone? Chiral carbon is the one which is sp3 hybridized and has 4 different groups, right? In a chiral carbon, you will see 1 to 4 priority you will give, right? 1 to 4 priority you will give, that you will give according to the CIP rule, that is highest atomic number will get the highest priority, and same isotope, more atomic mass is going to get the more priority, and also remember that cis is going to get more priority as compared to trans. So these are the 3 rules of CIP which we are going to apply, right? I know this can get a little bit confusing now. Don't worry, I am here. Don't worry. We will do examples from organic chemistry is not theory, guys. You can't learn it from rules and okay, done. No, it is not done like that. You have to see the examples. Only from that you will understand what exactly is happening. Okay. As of now, just understand what is the rule, right? What I am stating by the rule. Now, when you apply the CIP rule, you will give the priority 1, 2, 3, 4, right? According to the priority from 1 to 4, it can be either clockwise, it can be either anti-clockwise, right? Now, based on clockwise or anti-clockwise, we will define whether it's R or it's S. Now, first is, if the lowest priority group, that means lowest priority group, the 4th priority is on the vertical position, right? Or you can say, instead of saying vertical, right, you can also say it is below the plane. It is below the plane. It is below the plane. Then clockwise will be R, anti-clockwise will be S, right? Then lowest priority group on the horizontal position. If you have lowest priority group, let's say this, lowest priority group is on the horizontal, here lowest priority group is on the vertical position. If lowest priority group is on the horizontal position, these things will change. For clockwise you will have S, for anti-clockwise you will have R, right? If you have, just remember this thing, for 4th priority group on the vertical position, that is below the plane, you will have clockwise as R, anti-clockwise as S. If 4th priority group is on the horizontal position, everything will change here, right? Okay, everybody. Oof, Rama Raju, oh my God. Yes, today I'll do that. Today, nobody can stop me to send you resonance PPT, right? Okay, today I'll definitely do that, right? Just spam it in the comment section. I check your comments and spam it. Then resonance PPT, resonance PPT, resonance PPT, I'll definitely upload it, right? What to do? There's so many tasks to do. I forget it only, right? So, understood? Now let's try to apply it in some examples, okay? So this is the example given to you. Firstly, we'll try to understand how to give the priority. So hydrogen is having the least atomic number, so always it is 4th priority, right? Out of this, carbon has atomic number 6, this is oxygen, this is nitrogen. Oxygen has maximum atomic number, so it is 1st priority, this is 2nd, and this is 3rd, and this is 3rd. Don't look into H3, H2OH, that we will not see only. Why? One step at a time, one atom at a time. Okay. Now if you see, this is 1, 2, 3, 4. Can I see that it is 1, 2, 3, 4? The priority is 1, 2, 3, 4. Isn't it anti-clockwise? Isn't it anti-clockwise? If anti-clockwise, I'll just write it as anti-C. Okay? It is anti-clockwise. And your fourth priority group is on the horizontal position. Fourth priority group is on the horizontal position. For this case, clockwise you will have S, anti-clockwise you will have R. That means the answer here is going to be R is the correct answer here. Is that clear, everybody? Is that clear? Yes, I will upload that. Right? R is the correct answer here. Right, everyone? R defines the correct answer here. Okay? Do let me know if that is. Yes, S changes to R because here this is horizontal position. Okay? Wait a minute. Nee. Is this anti-clockwise? No, this is clockwise only. Nee, anti-clockwise. So sorry. Right? This is anti-clockwise. Yes. Okay? Yes. Chalo. Sometimes you do such high level things that you get confused in low level things. Right? So, now next is, if you have here, this is fourth priority group. Chlorine is maximum first priority group. Now out of CH2, CH3 and CH3, this carbon is connected to 3 hydrogens. If I want to draw it like this, this is CH3, this is CH2, CH3. So what we can do here, how we can draw it, we can also draw it like this. Wait a minute. We can also draw it like this. This is CH3, right? This is CH. This is CH, right? This is how we are going to do it. Now see this thing, right? C, here it is connected to 3 hydrogens. This C is connected to 1 carbon and 2 hydrogens. So definitely this will cancel. Here 1 hydrogen and 1 carbon you are left with. So that means this has more priority. So this will be 1, this is 2 and this is 3. Okay. So now can you see that it is actually 1, 2, 3. Just see 1, 2, 3. Fourth you don't need to include in the clockwise or anti-clockwise position. Now if you see, this is 1, 2, 3. Right? Which is clockwise. Now when you see that this is clockwise, now guys tell me, fourth group is on the vertical position, right? Now for clockwise, what will happen? You will have R as the correct answer. So here answer will be R. Yes? Sometimes it confuses in basics, we end up doing silly mistakes. Yes. No, Bhardwaj, that will be because this is on the horizontal position. So on the horizontal position, whenever you have anti-clockwise, right, that becomes R. This is like in horizontal, when fourth group is on the horizontal, things changes, right? This is what I told you in this rule. When lowest priority group on horizontal, clockwise is S, anti-clockwise is R. Okay, that you have to remember. Right, this becomes R here, so write it down over here that this is R is the correct answer here. Right, okay. Next question everybody, next question everybody. We have, next question everyone, let's see if you can define this or not. If you see this here, this is the lowest priority, this is for hydrogen will always be lowest priority. Out of this, bromine will be first priority, it has highest atomic number. Here you have oxygen, here you have carbon. Don't look for ma'am, this is ma'am carbon, ma'am 2 oxygen. Sometimes students get confused in this ma'am. Double bond oxygen ma'am, only single bond oxygen. No. See what it is connected to. It is connected to carbon here. It doesn't matter what is next to it, right? It doesn't matter. As soon as here also if it is carbon, as soon as it does not get cancelled, it will not matter what is next to it, right? So here this is carbon, this is oxygen. I'll prefer obviously oxygen here. This will be 2, this will be 3, and here when you define the clockwise or anti-clockwise, it will be this case, right, which is again anti-clockwise, right? Okay everybody, now it is anti-clockwise, okay, tell me anti-clockwise in case of when fourth priority group is on the horizontal position. Remember, usually in general cases when fourth priority group is on the vertical position, it will be R, it will be S, right? But now S is changed to R here, right? So answer will be R is the correct answer here, right? Okay, yes, R is the answer. So R is the correct answer. It should be S, but because here it is, see what is exactly happening, we are defining that rule for when H is on the vertical position only. But when you change the configuration, this configuration will also invert, no? So that's why R gets changed to, S gets changed to R here, right? And that is why answer will be R is the correct answer here, right? I don't like extra pages, right? So here everybody, let's see if you can define it or not. This is fourth, definitely. Over here you will have, let's say I say this as, I take this as A, this is B and this is C. In case of A, it is connected to 2 hydrogens and 1 oxygen. In case of B, it is connected to 2 oxygen and 1 hydrogen, because it is what? It is double bond OH. That means it is connected to 2 oxygens and 1 hydrogen, right? Double bond means 2 times. Triple bond means 3 times. This is CH3. This means this is connected to 3 hydrogens here. Can you see here? C will cancel. H will cancel. Here you have HO. Here you have OO. Here you have HH. So definitely this will have highest priority. So B will have highest priority. That is 1. Right, because it has 2 oxygens here. This is 1 oxygen, 1 hydrogen, less priority than this. So here it will be A after this. This will be 2. And this will have the third priority. Right. Now if you see, it will be 1, 2, 3. Again what I can see, it is going anti-clockwise. Right. It is going anti-clockwise, right? So when it is anti-clockwise, what you will do? Anti-clockwise, guys. Tell me what will be the answer here? For anti-clockwise, let's see if you can tell me the answer here or not. Yes, everybody. Anti-clockwise, thank you so much for your dedicated efforts. You only hope for giving JEE chemistry lectures. Please do lectures or chemistry chapter this manner. Thank you so much. Don't worry, Lokesh. We are here, right? We are here for you. You don't need to worry about. But one thing, I am very upset, right? And so much efforts I put. So such a beautiful, comments you are writing. But why don't you write it in the comment section so that it can stay with me? Chats will vanish. Comments will not vanish. I want it to stay with me. When you will pass out also, I want it to stay with me. Right? Okay, so write it down, because these things, these small things matters to me. Yes, I look for these things. These are my motivational source. Right? This, everyone needs some dopamine. This is my dopamine. Right? This is my happiness. When I see these kind of things that, okay, students are happy, they are able to understand, it pushes me to do more and more and more, right? So we also need efforts from your side. One is, please do your homework. Next, if you have something to say, any feedback, positive, negative, write it in the comment section. Negative feedback will help me improve. Positive feedback will make me happy, right? So both things are important in life. So here if you see anti-clockwise, fourth is on the vertical position. Anti-clockwise means S and there will be no change here. So answer will be S is the correct answer. Tell me, is that clear to everybody? Anti-clockwise is generally S. If fourth group is on the horizontal position, then it is changed to R. Clockwise is R. If fourth group is on the horizontal position, then it is changed to S. Tell me, is that clear, everybody? Is that clear? Only in horizontal it will change. Otherwise, it is not going to change. Okay, everyone. Do let me know if you have any problem in R and S calculations. Guys, if there is any problem in the calculations of R and S, do let me know in the chat box so that we can start with the next. What is its application? Yes, let's do that. Let's do the application. We are also going to do the PYQ based on this, right? So, if you see R and S, what it is going to give you, right? For example, two compounds are given to you, right? Now, if both the compounds have same molecular formula, right? So, how you will see whether it's a mirror image or not? You can't take that compound in exam, they will give you a mirror, then you will see whether it's a mirror image or not. This will not happen, right? So, what exactly, how, when you will see a compound, two compounds with same molecular formula, how can you say that whether they are mirror images, whether they are same, how will you define it, right? So the simple thing is, because when you see the compounds are quite complicated because they will be dashed, they will be solid. It's very difficult to directly see whether it's mirror image or identical. So the best way is, and which is the most accurate way and which will never lead to a wrong answer, is see what is the configuration, right? If in that question, usually you will have questions of only one chiral carbon, right? I'll show you PYQ, latest PYQ where one chiral carbon was there and you have to find whether it's mirror image or it's identical. That was asked to you. So if both the compounds are R, that means same configuration is there, then they are identical. Whether it's R or S, if same configuration is there, they are identical in nature. If both the structure, one is R, one is S, then we can say they are mirror images of each other, and to be specific, they are non-superimposable mirror images, right? They are non-superimposable mirror images, right? Non-superimposable mirror images, right? Okay, understood everybody? That you will see here, right? Now, let us see what is exactly, what do you mean by these things? Identical means superimposable mirror images. Mirror image will be there, but they are superimposable, right? Enantiomer means non-superimposable mirror images, and distereomers means no mirror image will be there, right? These are the definitions of enantiomer, For example, this is my hand, right? These are mirror images of each other, but when I superimpose them, they are not it is not completely hiding each other, right? So they are non-superimposable mirror images of each other, right? Okay. Now, if I see this A, this mirror image is A. Its mirror image is A only. And if you put it here, if you put this here, it will be superimposable, right? So that is why these are identical things, right? Okay, let's talk about this. Now you have to tell me what is exactly the condition here, whether they are superimposable, whether they are non-superimposable, what exactly is the condition here, right? Everybody, this is a simple molecule that I have given you here. A simple, easy peasy molecule I have given you here, and I see likes are very less today. Very few students are liking this session, very few students are interested. I see first lecture you will be super excited. You will see that any playlist you go to on YouTube, any teacher you go, First will be lecture will be super excited, students will be, then it will drop. And a student who is in IIT is the one who stays there till the end, the last lecture of that chapter. Because when you go it till the end, important thing starts, and that is where you lose motivation, because consistency is not there, right? So that has to be there. So if you see this here, this is fourth priority, right? This one will be first priority, this one will be second priority, this one will be, this is deuterium, that will be third priority. Here what it will be? This one will be first priority, this is second priority, this is second priority, this is third priority, this is fourth priority. If you see this here, in this case, this is 1, 2, 3, right? That is anti-clockwise. This is 1, 2, 3, that is clockwise, right? So in case of anti-clockwise and this is clockwise, we know that a fourth priority group is on the vertical position. We directly say that for anti-clockwise it will be S, right? For anti-clockwise it will be S, for clockwise it will be R, right? So answer is direct. They will be mirror images of each other, they will be enantiomers, okay? They will be enantiomers, they are not identical, they are enantiomers, okay? They are enantiomers, right? Okay, yes. Now, next is this one. Let's see if you can find this out or not. Two compounds are given to you, you have to find whether they are identical, they are enantiomers, right? How do you find it out, right? So simply, firstly, this is fourth, this one is the first priority, this will be second priority, this will be third, because this is carbon. Don't look for this oxygen, only see the first atom here, right? In this case also, this will be fourth, this will be first, this is second, and this is third, okay? Now when you see clockwise, anti-clockwise, this is going to be 1, 2, 3. This is anti-clockwise. This will be 1, 2, 3. This is clockwise. So in case of anti-clockwise, in this case, here fourth priority group is on the horizontal, there it is vertical. See, here this is on horizontal position. For anti-clockwise, it should be S. But because it is on the horizontal position, it is converted to R. Here, this is on the vertical position. For clockwise, it should be R, and that is correct because fourth priority group is on the vertical position, right? So can you see both are same? Both are same. That means they are identical to each other. They are identical. When you rotate it, no? When you rotate it like this, when you rotate it, this CHO, right? This will be CHO. When you rotate it like this also, this is hydrogen, this you have to hydrogen. Okay, this is Br opposite this. Achha, this you have to do even odd exchanges. From that it will get identical. Okay, yes. See, directly you can't tell that this is identical. If you see, now you have to even odd exchanges means, if you even odd exchanges means when you interchange opposite positions one time, configuration will change. For example, let's see, for example, you have this thing, right? For example, even odd exchanges means, for example, I want to change here what we have CHO with Br, here we have CHO with F. So I want to have on the CHO with Br. So I'll exchange this. I'll exchange this. This will become CHO, this is Br, this is H, and this is F, right? Then here this is CHO. CHO on one side you have Br, one side you have H. For H, one side you have CHO, one side you have F. For Br, one side you have CHO, one side you have F. Okay. So that is odd exchange that we have done, right? So here, if the configuration here is what? Configuration here is, wait a minute, why then it is coming out to be opposite? 1, 2, 3, it is anti-clockwise. Anti-clockwise will be R. Yes. And here it is 1, 2, 3, it is clockwise, so it has to be R. And if this is R, then when I exchange it, this will come out to be, wait a minute, this will come out to be S, right? Then further, what we have to, further we have to rotate it. See, this is R, this one is R. Further, I have done one odd exchange. With one odd exchange, its configuration will change from R to S. So this will change from R to S. Then I rotated it. Rotated it means I rotated, this was CHO here, I rotated it with this angle. Because of that, again it is converted to R. And this is a way to understand this, right? Otherwise, you can directly just calculate and see whether they are same or different, right? Okay, everybody? Cool. Now, let's talk about next part, that is when you have two chiral carbons. With two chiral carbons, what you will do? If two chiral carbon means this kind of compound where this is chiral, this is also chiral, right? You have to see here. Two chiral carbons, if both are opposite, for example, I'll just tell you here, both are opposite, what do you mean by that? This is also chiral, this is also chiral, this is also chiral, right? If let's say both are opposite means this is R and this is S, this is R, this is S. These two are opposite, or you can say this is SS, this is RR, both are opposite, right? Or you can say this may be R, then this will be S. If this is S, then this is R. Or you can say if this is S, then this is R. If this is R, then this is S. That means always those carbons will have opposite configuration. If both are opposite, then that is enantiomer. If both are same, that means if this is R, this will be R. If this is S, this will also be S. If this is S, this will also be S. If this is R, this will also be R. That is when both have same configuration, that will be identical to each other. But when one configuration is same, one is different. That means this is R and this is S. This is R, but this is also R. First case, right? Then you can see when this is S, one is same and the other is opposite, right? Or you can see like these, you can have so many multiple permutation combinations you can have, right? All in all, what you have to remember, we are talking about the corresponding carbons here, right? Not between the same molecules, with each other I am talking about whether they will have same carbons or they will have different carbons, okay, right? Now let's talk about this. If you see this here, these have two chiral carbons. This is chiral carbon, this is chiral carbon. Now you'll have to see the configurations here, okay? Let's see the configurations. Here in this part, this is fourth priority. This is chlorine is first priority. In this carbon, this is connected to a carbon. This is also connected to carbon. This is connected to a carbon. Here, I am taking this as a group. This is a group. Out of these two groups, this group will have more priority because carbon-carbon will cancel. This carbon is connected to 3 more carbons. This carbon is connected to Br here. So that's why this will have more priority. So here it will be, wait a minute, yes, 1, this will be 2 and this will be 3, okay? That is going to be the priority. Now, when you see this, this is 1, 2, 3. That means this is clockwise. In clockwise, when it is horizontal, in clockwise it should be R, because of horizontal it becomes S, right? So we can say this one is nothing but it is S, right everybody? Just give me a second guys, just give me a second. Hello, hello, hello. Yes. Why the students have vanished? What is the scene, huh? Chalo, I'll not see you only. You guys, ma'am, something good you are teaching, then will vanish. Okay. So this is going to be S. Now let's talk about this one. This is fourth. This is the first, right? Bromine 1. In this case, this group will be more priority, because if you see this here, this group will be having carbon then chlorine. This group will have carbon then hydrogen. So that is the reason this group will have more priority. So this will be 2 here and this will be 3. Okay. So 1, 2, 3, and here you will see it is 1, 2, 3. It is anti-clockwise. So anti-clockwise, and this is on the horizontal. For anti-clockwise, what should happen? Anti-clockwise it should be S, but because it is on the horizontal position, it will become R. So this is R. This is S, this is R, that is clear. Now let's talk about this one. In this case, this is the fourth priority, this is the fourth priority. This will be first priority. This big group will be second, because carbon then bromine. Here you have carbon then hydrogen. So this will be second and this will be third. Right? Now here you have 1, 2, 3. Right? This is opposite. That is 1, 2, 3. 1, 2, 3. That means this is anti-clockwise. Anti-clockwise should have S, because this is on the horizontal, so it will have R. So that means this position is R, right? Configuration is R. In this case, you have fourth here, this is first here, this is second here, and this is third here, right? Because here second, because of this big group here, and this is going to define, if you see this, 1, 2, 3, isn't it clockwise? This is clockwise. For clockwise, what you have? For clockwise, it should be R, but because it is fourth group on the vertical position, on the horizontal position, it will become S. So that means here it will be S. So can you see it is S opposite R and R opposite S. And I told you when both are opposite, then it is going to be enantiomer, right? When both are opposite, then it is going to be enantiomer. So you can say that these are enantiomers of each other. These are enantiomers of each other. Let me know, is that clear? Right? Thank you, thank you. Okay. Why you need this method? I'll tell you. Because directly these things are all still easy. This method is needed because otherwise you can do mistakes, right? Otherwise mistakes are easily possible, right? These are even odd exchanges that we have directly, guys. I just told you this before also. This is first priority, this is second, this is third, this is fourth. I'll just write it here as well. 1, this is 2, this is 3, this is 4. And this is 1, 2, 3 and 4. Now just write R and S here. Just write R and S here. What you will see, this is 1, 2, 3. This is anti-clockwise. Hydrogen is on vertical. For anti-clockwise, it will be S. It is anti-clockwise. Hydrogen on horizontal, it will become R. Anti-clockwise gives R. This is 1, 2, 3. It is clockwise, and clockwise usually is R, but because it is on the horizontal, it will become S. Now, ma'am, but why we are seeing this? What is the benefit? See, this is SRS. Wait a minute. Let me just draw that again. Right. Now let's talk about the exchanges that you have. SRS now is simple. Right, now let's talk about the exchanges that you have. In this case, if you can see fluorine, chlorine, hydrogen, can we see that these two are exchanged with each other? Hydrogen and chlorine are exchanged. So there is one odd exchange. One exchange means odd exchange, right? Now here, this is fluorine, bromine, and these two are exchanged with each other. Another exchange, that is another odd exchange, right? Overall, this is a 2 exchange, that means overall this is even exchange. One exchange is odd exchange, and here 1 plus 1 means 2, that is even exchange. Now what we have seen, this is S, R and S. Okay, let's apply it here. This is S, this is R and this is S. So what we saw here, that with odd exchanges, configuration is changed. One exchange will change the configuration, one exchange will change the configuration. But with even exchanges, with 2 or 4 or 6 or 8, right, with a multiple of 2, if you have any exchanges, that will be, configuration will remain intact. Okay, understood everybody? Do let me know, right, if that is clear, right? Okay, now let's talk about DL configuration. Let's talk about DL configuration, everybody. Do let me know if you are ready for DL configuration. Right, everyone? Ready? Yes? Okay. So let's talk about DL configuration. In DL configuration, right, capital D, capital I am talking, not small d, small l. Small d, small l are levo, dextro, that we can't define by just looking at the compound, right? That will be defined experimentally. But DL configuration, capital D, capital L, you can define here. Very simple it is. Now, here first condition is oxidized group should be on the top. Then last chiral carbon, if OH or NH2 is on the right side, it is D. If OH or NH2 is on the left side, it is capital L. Remember this by DR. Diksha Ma'am is always right. Okay. So, or you can remember this by doctor, anything you like. Right. So, here what you will have, capital D configuration means OH or NH2 in the last chiral carbon will be on the right side. Okay, let's see an example of that. If you see, last chiral carbon is this one, last chiral carbon is this one. Here OH is on the left side, so this will be capital L. Here OH is on the right side, that will be capital D. Okay, this OH is going to define the DLN configuration. Now, let's see this here. What about this one? Last chiral carbon is this one. This is the last chiral carbon. See, this is also chiral, but this is the last chiral carbon from down. Okay. Here OH is on the left side, so it will be L. Here OH is on the right side, so it will be D. Okay, everybody, got it? Now, let's talk about this one. If you have NH2 present in that compound, if you have NH2, now NH2 is dominating as compared to OH. Now, if you see from the logic, you will say that, ma'am, last chiral carbon is this one, OH is on the left side, it should be capital L. But in reality, here what you will see, that NH2 will give you the configuration, not OH. So when you have OH and NH2, forget about last chiral carbon, just see where you have NH2. If NH2 is on the right side, this will be D configuration. So if NH2 and OH, select according to NH2. Don't worry about the last chiral carbon if both are present here. Right, everybody? Do let me know in the chat box if that is clear to all of you or not, so that we can do the next definition, that is epimers. My energy is going down, guys. By seeing your energy, my energy is literally going down, and I have to teach for next 1 hour. And if I see you like this with so less energy, then I'll give you everything for homework. Then you do this yourself, and then tell me how it was easy or difficult, right? Level up your energy a little bit, right? Everyone here. And why the other students are not here? What is, and I feel because it is 6 p.m, maybe some students are not, maybe some, coaching, or, I see, some students, they comment down that, ma'am, we watch your recorded videos, ma'am. Please, ma'am, teach us fully, ma'am. We watch your recorded videos at night or in the morning. So, okay, if you're watching the recorded videos, write it down in the comment section, right? Okay, so now let's talk about epimers here. If a molecule has more than one chiral atom in it, only one chiral carbon is different, that is called epimer. For example, you have this one. This is also chiral, 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 this is also chiral. Now, in these, you have H, OH, OH, H, Br, H, no, this is opposite. Can you see? This is opposite. H, Cl, Cl, H. That means when you have more than one chiral carbon atom and only one has different opposite configuration, that means this has opposite configuration, that means these will be called as epimers of each other. Okay, these will be called as epimers of each other, right? What are anomers? Anomers are cyclic epimers, right? So this structure, if you see in biomolecules, you will understand more about these structures, right? Right now, I'm just showing you this structure, that this is also chiral, this is also chiral, 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 right? All of these are chiral. But here on one position, you will see the opposite configuration, right? If you see, the opposite configuration will be there on this position, right? This particular position has opposite configuration. That means they are epimers, and cyclic epimers are called as anomers of each other. Okay? Cyclic epimers are called as anomers. Next definition is thereo and erythro compounds. So what are thereo, what are erythro compounds? Let's talk about that. Thereo compounds are where you have same atom on the same side, that is erythro. When you have same atom on different sides, opposite sides, then they are called thereo. Okay, so let's talk about this with the help of an example. If you see this here, guys, then Cl and Cl are on the same side, right? So this will be called as erythro. Okay, and here if you have Cl and Cl on the opposite sides, that will be called as thereo. So these are the names that are given, and they can directly ask you which of the following is erythro, which of the following is thereo, which of the following is D, which of the following is L. Definitions are simple. Which of the following are epimers, or which of the following are anomers of each other. So these are direct definitions that they can ask you. Based on statement based questions also can be asked to you, right? Okay, everybody, right? Okay. It is not related, but these things you will use, yes. These things that I am telling you here, these you will use in biomolecules, right? Okay. Yes, everyone, let's do one question of JEE Mains 2022, everybody. So, given below are two examples. Now, Rama Raju was asking again and again, ma'am, why we have this method of R and S, okay? Because to solve questions like these, this compound is given. With this such complicated compound, can you tell whether they are mirror images of each other or not? Isn't it so difficult to define? You can't have that much imagination that you will form a mirror image of this, whether it is related to this or not. Very difficult it is, right? And probably you will end up doing wrong. That is why R and S configuration helps us, right? If R and SS, if both have, this also have R, this also have R, or this also has S, this also has S, then they will be identical, right? But for example, if one has R, one has S, one has S, one has R, then they will be mirror images of each other. That means this second statement that they have given you, that this particular compound is a mirror image of this compound, that we can define by solving R and S configuration only, right? There are other methods only, but it will be difficult for you to answer that, right? The compound, this is optically active, that you can easily tell, right, everybody? But tell me, are you guys like not interested in like understanding or learning something? Because this is the end of this topic. After this, I'm going to start something else, and if you're not interested, I'll just end the class then, right? Because after that, we'll have conformers of alkane, and we will have structures, like calculation of isomers. And for that, this kind of chat I can't teach with, right? I can't teach with that. I don't want to spoil my mood, my energy, and also your mood. You need proper energy from this teacher, and even I need proper energy for you as well, from you as well. If you're not interested, then do let me know. I'll just end the class, okay? Right? So, this, by the time I'm solving this question, you can tell me. If I don't get any response, then I'll just end this class, right? Because there is no benefit of me and yours as well, right, in doing classes like these, right? Okay. Rama Raju, only for this. What about other students? Rama Raju is saying that yes, ma'am, please continue. What about others? Not interested? Chalo. This is compound A. Okay. Compound A, if you see, this is the carbon. This NO2 is different. This hydrogen is different. This compound here, which has one carbon double bond, then CH3. This also has one carbon double bond, then CH3. Now, usually students mark this as false statement. Why? Because, ma'am, this particular, wait a minute, I'll just copy paste this. This is a very important question that was asked in 2022. And trust me, students lose marks from isomerism. They tend to lose so many marks from isomerism, right? So, let's see this. Let's see this. I'm not going to give the priority here, right? Let's only see, firstly look for the chirality, whether it's chiral or not, right? Okay. See. For a chiral carbon, for a chiral center, what should be there? It should be sp3. All 4 different groups should be there. That is the condition, right? And if you see this here, this is the carbon that we are looking at. This group is different, this group is different. But ma'am, what about this group here? This is carbon, carbon double bond, carbon CH3. This is also carbon double bond, carbon CH3. So these 2 groups are same, and in hurry, students write that these 2 groups are same. This is achiral, first statement is incorrect. And this is where they go wrong. This is where mistakes happen. Let's see how. Can you see here you have hydrogen, in this case hydrogen here, right? Can you see that here you have hydrogen here and hydrogen here? Now, bacha, can you tell me that here this is actually cis and this is actually trans, and cis and trans are two different compounds, right? Cis and trans are two different compounds. This compound is trans and this particular compound is cis here. So you have two different compounds here. That's why this particular carbon is going to be chiral in this case, right? This carbon is going to be chiral because you have two different cis and trans here. This is a major mistakes done by the students, right? Ma'am, why it is chiral? Ma'am, group is same because cis and trans are two different compounds, right? Okay, so the first statement is not false, first statement is true, right? What about this statement? This is your JEE 2022 question, and these two questions can be easily repeated, and students do mistake, they have done mistake in these kind of questions, right? Okay, so this is the compound is a mirror image of above compound. Let's see that, right? Now let's see the priority. Hydrogen will be fourth, nitrogen because it is nitrogen, so it will be first. What about this and this? Guys, this is cis and this is trans. So which one has more priority? Tell me. Which one has more priority, cis or trans? Everybody. So I told you before also that cis will have more priority. Do you remember that CIP rule where I wrote cis has more priority as compared to trans? So that's why this is first, this is second. That's why the priority is, this is first priority, this is the second priority, then there it will be the third priority, and hydrogen will be the fourth priority, right? Now if you define it priority basis, it is going to be 1, 2, 3. That means it is going to be a anti-clockwise. Anti-clockwise and below the plane, that means it is going to be capital S. S is going to be the configuration here. What about this one, everyone? What about this one? If you see this here, the priority will be simple. Hydrogen will have fourth priority, nitrogen will have, this is connected to nitrogen, right? So this will have first priority. This one is your, this is hydrogen, so this is trans. This one is, this is hydrogen, this one also will be hydrogen, so this is cis. So cis is going to have more priority, so you can write this is 1, this is 2, and this will be third. So that's why here you have 2, that's why here you have 2, and here you have 3, right? So 1, 2, 3 and 4, if you see, this will be 1, 2, 3, 1, 2, 3. Can you see this is anti-clockwise? This is anti-clockwise, and when you have hydrogen, that is below the plane. This is below the plane. This dash means it is below the plane. When it is below the plane, we can say that it will have S configuration. Yes, so it will have S configuration. That means it is going to be identical. It is going to be identical, right? Identical means they will have superimposable mirror images. So answer will be yes, that second statement, it's a mirror images. Acha, nahi, identical does not means, here they are asking you mirror image of A, right? That means they are talking about enantiomer here. They are talking about enantiomer. For enantiomer, this has to be opposite. If this is R, this will be S. If this is S, this should be R, right? That means these are identical. They are not mirror images of each other. So that is going to be a false statement here, right? Okay. Identical means they are same only, right? Superimposable mirror, ma'am, you said ma'am superimposable mirror images. Yes, they are superimposable mirror images. But when they ask you mirror images, they don't want to ask superimposable, right? Superimposable mirror image. Okay. Superimposable mirror image means they are identical only. They are same only. like how twins look like same. So if they ask you mirror images, they are talking about non-superimposable mirror images. They are talking about enantiomers here, right? Because if they are superimposable mirror images, they are same only, right? Okay, so these compounds are same only. So they are not mirror images of each other. We need non-superimposable mirror images. So we can say first statement is correct and the second is incorrect. So C is going to be the correct answer here. Do let me know guys if that is clear to everybody so that we can start with the next part, that is, this is a good question to learn more. Yes. Now guys, let's talk about the next question here, next part here, that is degree of unsaturation, right? Let's talk about guys degree of unsaturation. Now in case of degree of unsaturation, firstly let's see what is exactly degree of unsaturation, right? Just give me a second, wait a minute, yes. So degree of unsaturation is also called as double bond equivalence. How many hydrogens are needed, or you can say unsaturation index, right? These are some names of degree of unsaturation, right? Degree of unsaturation, unsaturation index, and index of hydrogen deficiency, right? Index of hydrogen, these all mean the same thing only, hydrogen deficiency. So this will define that when you have a double bond, right, to break this pi bond you will need 1 mole of H2. That means 1 degree of unsaturation is required. 1 H2 means 1 degree of unsaturation. 1 H2 means 1 degree of unsaturation, that means 1 pi bond. When you have 2 pi bonds, you need 2 mole of hydrogen, that means 2 degree of unsaturation is required. When you have a ring, to break this ring, you need 1 mole of hydrogen to convert it into open ring. So for a ring also, we define it by 1 degree of unsaturation, right? So degree of unsaturation simply means that the amount, the moles of H2 that you require to break 1 pi bond or to break 1 ring. That means in simple languages, we can say that 1 pi bond is 1 degree of unsaturation. 1 ring is also defining 1 degree of unsaturation, okay? 1 ring is also defining 1 degree of unsaturation. 1 pi bond is also defining 1 degree of unsaturation, right? Now, let's understand this in more detail. For example, let's understand this now with the help of a formula. For example, okay, let's see. Firstly, let's understand this with the help of a structure only, right? Okay. Now, if I draw this structure, right? If I draw this structure, right? If I draw this structure, okay? And if I draw this structure, okay, tell me how many DOU are, degree of unsaturation are required in each case. This is A, this is B, this is let's say C, and this is D, okay? How many degree of unsaturations are required? 1 pi bond gives 1 degree of unsaturation. Here you have 1 pi bond, 2 pi bond, that means 2 DOU will be required here, 2 degree of unsaturation. This is 2 pi bond, and after breaking these 2 pi bonds, you will have a ring also here. That's why this ring also will give you 3 DOU, that means 3 degree of unsaturation will be there. In this case, what you will have? Degree of, don't say mole, say degree of unsaturation, okay? It's named as degree of unsaturation. This is one pi bond, one ring also will break, so it will be 2 DOU, 2 degree of unsaturation. In this case, you will have a pi bond here that corresponds to 1 degree of unsaturation. Then you will break this ring that corresponds to 2 degree of unsaturation. So 1, 2 degree of unsaturation. I don't know what is happening with me. I am little bit tired, I think. Unsaturation, I am talking something else only. So that defines the degree of unsaturation, right? Now, let's understand that, for example, ma'am, structure is not given. If the structure is not given, then this will be the formula. That is also written as, C, that is also written as C plus 1 plus n minus x minus h by 2. I think that should be plus h by 2. Wait a minute. Yes, n minus x minus h by 2, yes. Okay, this is how you can also write it. Now it's totally your choice how you want to solve it with this, like these are same things only, I just divided this thing by 2, right? You can remember 2c plus 2 plus n minus x minus h. 2c plus 2, 2c plus 2, nxh, okay? N minus x minus h, okay? That is the, where this C means number of carbons, N means number of nitrogen, X means number of halogens, H means number of hydrogens. Using this formula, and this you will use in JEE mains, questions are asked based on unsaturation, they are asked, okay? So this is a simple formula from where you can calculate the degree of unsaturation. Now understand, I'll give you one question here, that is C5H12, okay? The question is C5H12. Let's see this. The question is C5H12, right? Now in this case, what is DOU? Degree of unsaturation, everyone. What will be DOU? Everybody in the chat box, what will be DOU? I'll just write the formula here. Formula is C plus 1 plus H minus X minus N minus H minus X. N minus H minus X or N minus X minus H divided by 2, right? This will be the formula. Number of carbon are 5, 5 plus 1. This is plus, nitrogen is 0, hydrogen is 12, and here halogen is 0. So this will be by 2. So this will be 6 minus 6, that is going to be 0. That means no pi bond, no ring. If DOU is 0, that means there is no pi bond, because one DOU corresponds to either pi bond or a ring. That means here you will have no pi bond and you will have no ring. Now, can you draw the isomers? In the exam, they will not ask you to calculate the DOU. Maybe they can also, but usually what they ask is calculate the number of isomers here. Now, let's see that how do you define the isomers? There is no pi bond, no ring. So, that means firstly I will write 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 simple. 1, 2, 3, 4, 1 branch here, or 1, 2, 3, 2 branches. Isn't it? Because no pi bond, no ring is there. So, with no pi bond, no ring, I can have these as my isomers. Is there any other possibility, guys? Any other possibility? Ring is not possible, double bond is not possible, because here DOU is coming out to be 0. So, this is how you make the isomers here, right? Let's talk about the next. Let's talk about next here. And here we have C4H8. C4H8. firstly you will calculate the DOU here, right? First you will calculate the DOU here. Now DOU is nothing but C plus 1 then plus N minus X minus H by 2, right? Carbon is 4 here, 4 plus 1 is 5, plus here nitrogen is 0, minus X is what? X is 0, no halogen, and hydrogen is 8 divided by 2. Here it will be 4 plus 5, this will be 8 by 2, that is 4. So it will be 5 minus 4, that is 1. Now this 1 DOU corresponds to maybe 1 ring, maybe 1 pi bond, right? Anything it can correspond to. So I can write this will correspond to 1 ring or 1 pi bond, right? This will correspond to 1 ring or 1 pi bond. Now you have to make all the structures here. Okay? Yes, everybody? Let's see. 1, 2, 3. If you put it here, there will be 1. Firstly, I am writing about double bonds. Double bond you can have here, double bond you can also have here, right? Okay, everyone, these are the two possibilities when you have open chain, N chain. Now branching also can happen, With branching you can have a double bond here and also see whether hydrogens are justified or not. 3, 4, 5, 6, 7, 8, yes, right? Here also it is 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. Yes, all of them have 8 hydrogens only. So that hydrogen also you have to check side by side whether they are like, hydrogen should not increase, right? So these are 3. Now is there a possibility, now if double bond only 3 possibilities are there. Now is there a possibility that it also form a cyclic structure, right? Now this can also correspond to 1 ring. So you can also have this as the isomer with 1, 2, 3, 4, 5, 6, 7, 8, same thing. This also can be the isomer. Isomer can also be if you have a propane here with 1. All of them will have 1 DOU. All of them have this particular formula, right? Now, firstly guys, tell me if till here it is clear. From this just one thing is given. These all we can define from just this formula, right? Now, number of structural isomers. I am not at all talking about chiral carbon, nothing I am talking about. Structural isomer is 1, 2, 3, 4, 5. Now, what if they ask you, they can also say number of isomers excluding stereoisomers, that is also number of structural isomers. Number of total isomers, structural plus stereo. Now everybody tell me for stereo what we used to see. Stereo is nothing but geometrical and optical. Geometrical will have double bond with that geometrical isomer condition, and optical will have chiral carbon with 4 different groups, right? So here there is no GI possibility, no GI, right? In this case GI can be present. So this you will calculate 2. Here you have no GI or optical isomer, this will be 1. This you will calculate it as, here also no GI is possible. So this also will calculate it as 1 only. No further stereoisomer will be formed here. This is no chiral is there, no optical isomer, no stereoisomer is there. Nothing is chiral. If you see this one is it chiral? This is having 1, same. No, this is also not chiral. So this also you will consider 1, this also will consider 1. So in total how many you will have? 6 will be the answer here, right? 6 will be the answer here. Do let me know guys if that is clear to all of you or not. Do let me know guys if that is clear, what is structure, how to calculate number of stereo and structural isomers in this case, right? Shall I do one more one more here, right? One more so that you will get more clarity on this, right? You will get more clarity on this and try to do this yourself, okay? Try to do this yourself. It will help you a lot. So, we have C4H10O. Firstly, what you need to calculate is DOU. DOU means you need to calculate degree of unsaturation, and degree of unsaturation has what? C plus 1 plus N minus X minus H divided by 2, right? Write it down here. C plus 1, carbon is 4 plus 1 plus nitrogen is what? Nitrogen is 0, halogen is 0 here, halogen, wait a minute, halogen is also 0 here, है ना? 10 by 2, 10 by 2, 5, this will be, wait a minute, this will be 0, this will be 10, oxygen we don't consider, na? Oxygen is not considered here. So this is 5 plus minus 10 by 2. Is it coming out to be 0? Yes, it is coming out to be 0. Right? No degree of unsaturation, nothing is there. Now you have to draw the isomers here. Let's do that. Okay? Now you have to draw the isomers here. Let's do that. 1, 2, 3, 4. And on 4 you can have OH here because this is 3, 4, 5, 6, 7, 8, 9. Right? 10 you can write over here with the OH. With this you can also draw 1, 2, 3, 4 and OH can be here as well. If OH is here, it will give the same result. If OH is here, it will give the same result. Now let's do the branching. Now guys, let's do the branching. Okay? Let's do the branching now. The branching is you will have 1, 2, 3. This will be your branching and this you can have OH here. Right? You can have OH here. Another thing can be you will have this thing. You will have this and here you will have 1 and here you can have OH. Right? These are the next two possibilities. Yes, ask what is your doubt. Right? Another possibility. Now, you can have oxygen in between also, like ROR, ethers you can also form. Alcohol and ether are isomers on each other. So, here what you can do is 1, 2, 3, 1, 2, 3, 4. This also can happen 1, 2, 3, 4 carbon. You can also have 1, 2 in between here. 1, 2, this will oxygen and this is 1, 2, 3, 4 carbon. This is normal, right? You can also have 1, 2, this is, wait a minute, oxygen in between you can have. This also will give you the same answer. And one will be another with a branching. If you have instead of this here, this is oxygen, this is 1, you can write it like this 1, this is 1, 2, 1, 2, 3, this also can happen, tell me. Right, so these are the possibilities. Is there any other possibility that is there? Is there any other possibility that is there? More chains you can't have. If you again have this carbon here, it will form the same thing as this one, right? So that means these are the possibilities that you have. 1, 2, 3, 4, 5, 6, 7. Okay. So you can say that, just copy paste this here and you can write it here. Number of structural isomers. Number of structural isomers. Why no double bond and no ring is there? Because DOU is 0, right? Structural isomers is 1, 2, 3, 4, 5, 6, 7. It is 7. Number of structural isomers is 7 and these are the questions that they ask you in JEE, right? Now, number of total isomers. Total isomers means structural plus stereo. Okay, structural plus stereo is going to be there. Here you have no chiral carbon, here this is the chiral carbon. So this will be considered as 2 because this will form a stereoisomer because of its chirality. Here you can see no chiral carbon, here you can see no chiral carbon, here you can see oxygen, this is no chiral carbon, no chiral carbon, here no chiral carbon. So that means all will be considered as 1, 1, 1, 1 and 1. Can you see in one question how many things are applied? You should know stereo, you should know geometrical. If there is a double bond, then you should know geometrical as well, right? You should know DOU, you should know the calculations, like you should know what is chiral, what is you should know the condition of geometrical isomerism as well. So all these things are applied in these questions, and these questions are asked to you, right? So answer will be 7 plus 2, 7 plus 1, that is 8, right? And that is going to be your answer. Do let me know, guys, if that is clear to all of you or not. Do let me know, guys, if that is clear to all of you or not. Everybody, is that clear? Is that clear? Right? How many stereoisomers? 2 stereoisomers. This and its other isomer. That is your 2 stereoisomers. Right? Okay, everybody? Right? Now we are going to see the next part, that is conformers. Next part is conformers, right? Last part of today's class, that is conformers of alkane. It's easy peasy and lots of questions are asked from conformers of alkane. It's actually there in hydrocarbons like alkanes, cycloalkanes. Especially they will directly stability order they will ask you, or energy order they will ask you, or there is an effect called Gauss effect, based on that they ask you, and it's direct question. It will not at all take time for you to solve it. It's very easy, very simple. Okay, let's do that. Everybody, let's do that. Okay, so if you see conformers here, conformers of alkanes are different spatial arrangements. So basically, just give me a minute. Let me just arrange one thing for you here. Right? Okay, tell me. You talk about alkene, right? We have talked about alkene. Alkene used to show no rotation. Isn't it restricted rotation? Isn't it restricted rotation, everybody? Because of restricted rotation, we talked about GI here, geometrical isomers here. But in case of alkane, can you see any restriction here? In case of alkane, what you have here is this one, okay? What you have here is this thing. This thing you have in the alkane. Isn't it alkane? Carbon, carbon, one single bond, 3 bonds here, 3 bonds here. This is alkane, right? Alkane has rotation. Can I rotate it? Can I rotate it? This bond is slightly too loose. So what I'll do, I'll have a like more stable bond here, which is less longer, right? Okay, yes. Okay, this one you will have. Now can you see this is easily rotating, easily rotating, easily rotating. Like a screw, I can rotate it, right? From this side also I can rotate it, right? From this side also I can rotate it. Now because of these free rotations, right, they develop a thing that is called conformers, right? So conformers of alkane are different spatial arrangement in the same molecule that result in free rotation about the carbon-carbon single bonds. So what exactly happens here? Around this bond, what can happen? First thing is this thing, okay? This thing is another structure. If you rotate it, a minute, this much, this will be some other structure, right? These are 2 different conformers because of the rotation, right? And that we are going to discuss here, right? Okay. let's see, I'll talk about that, right? Let's talk about this here. Now, the idea about conformers is that methane has no conformers. Can you tell me why methane has 0 conformers? Why methane has 0 conformers? If you see, this is methane, right? Now with rotation, it is rotating, okay, it is rotating. Is it giving some different answer here? It is rotating, it is giving the same thing. Whether it's rotating, it's giving the same thing. So by rotation also, there is no difference in the way this compound looks like. That is why methane has 0 conformers, right? Now let's talk about ethane and the higher compounds. They have infinite number of conformers, right? We discuss some specific conformers, right? Like we'll discuss staggered, eclipsed, these structures we'll discuss. It's not like they have only 2 conformers, right? When the question is asked how many conformers methane has, it has no conformers because the difference it does not make, right? But here if you see, if you rotate it with, wait a minute, this angle is very difficult to rotate, right? I need like something more solid here, right? Okay, now I think it will be easy. Now see, if I rotate it this much, angle is little bit fluctuated. This much, again angle is different, this much angle is different, this much angle is different. With every 0.001 degree change in the angle, a new structure will be obtained. A new structure will be obtained with every 0.000001 degree change in the angle. So if we are looking for only 2 structure, doesn't mean it has only 2 conformers. It simply means it has infinite number of conformers. At every single angle, it has a different conformer. 360 degree rotation is needed. So between that 360 degree, this is the starting. If you see, this is the starting, right? Wait a minute, let me see if you can see this or not, right? Wait a second. Yes, I think now you can see it, right? If you see this here, right? Yes, if you see this here, can you see now the previous one? You can only see this CH3 group here. You can't see the back carbon here, right? You can only see the front carbon. When I rotate it a little bit, can you see it? Yes. I rotate it a little bit more. Can you see it? Yes. Little bit more. Can you see it? Yes. Can you see it? Yes. So similarly, when I do 360 angle rotation, right, again it will come to the same point where you will see that the back carbon is totally vanished here. It's not actually vanished, it is hidden somewhere, right? Can you see that? Everybody, can you see that? Right? So this is what we call conformers, right? So that's why there are infinite number of conformers here. But we'll talk about one by one 2 conformers of ethane. So let's talk about conformers of ethane. There are 2 conformers, one is staggered, one is eclipsed, right? So I'll show you this way only, right? Okay, everybody, guys, please don't spam in the chat box, right? Okay, please don't spam in the chat box. But Eklavya is different, right? This paper, but Eklavya is also for your JEE Advanced, right? Okay, so that's totally your choice. What's your aim? According to that, you can choose, right? Okay, yes. Now let's see this here. Ethane has infinite number, but what we'll see here now, see this, okay? This is the structure here. Now what is an eclipse? What is an eclipse? Eclipse, when we talk about solar eclipse, right? Moon eclipse, what do you mean by that? Right? That the sun will hide somewhere, right? The moon will hide. That is called eclipse. Similarly, here we will have eclipse, right? The back carbon will hide somewhere, right? If you see this here, wait a minute, let me just show you at an angle where you will see these will be completely hidden. Wait a minute. Okay, now can you see they are completely hidden? You can only see this CH3, but in reality it is CH3 back carbon is also there, but you can't see it, right? So here this is called eclipsed, but when we have 60-degree angle, right, this structure is called, this structure, I'll just hold it from this space, this structure is called as staggered. Wait a minute, when I change my position, this also changes. Can you see this particular is called as staggered? When the front carbon, all the hydrogens, you can see the back carbon, all the hydrogens also you can see. That is called as staggered. Okay, so eclipsed and staggered are these two things. Are you able to understand, everybody? Right? Yes. Surya Grahan conformer. Yes. Right? So this is staggered means when theta, the dihedral angle, the angle that you have here, that becomes 60 degree, and eclipsed means when the back carbon is hidden, that becomes 0 degree. Okay. So this is how we show it by the Newman structures. Right. Now you can say, ma'am, what is Newman structure? So again, let's talk about Newman structure. Right. Okay. Let's talk about Newman structure. Wait a minute. Let me just talk about Newman structure. See. Okay. This is the carbon. This is how it looks like. Okay. Now, guys, two kind of structures we have. I'll just show you. We have more structures as well. I'll just firstly draw. When you see it from the side, let's say this is your front carbon, right? This is the front carbon, this is C. This is the back carbon. Here you will have 1, 2, 3. 1, 2, 3. These are the, this is seahorse position. This is seahorse structure. But this is not useful to you. Now same thing, this is how the side angle looks like. For me, this is first carbon, second carbon, 3 groups are there. For front carbon, 3 hydrogens are there. Back carbon, 3 hydrogens are there. But when I talk about, when I draw this in Newman's, this means how it looks from the front. This means how it looks from the front. From the front, how it looks like. You can only see the front carbon. So the front carbon you draw by this big circle, and the hydrogen that you have on the front carbon you will draw with the solid line. And the back carbon that you are not able to see, the back carbon, if you see here, if I just slightly, rotate it like this a little bit. Now can you see it is completely hidden? Can you see, just with a little angle it is completely hidden, right? Can you see that? That means back carbon will not be shown, it will be hidden, right? So back carbon we draw this simply by this dot, and from that dot, dash, 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 dash you will draw. With that dash, dash, what will happen? Dotted line basically, right? You will have back hydrogens. Now two kind of structures are possible in this case, right? When you talk about a structure, right, in which front carbons you can see, right, but the back carbon are completely eclipsed here. This is how seahorse shape looks like. This is how Newman structure will look like. This is how Newman structure will look like. Okay. Now the back carbon is completely hidden here, right? And the hydrogens also are completely hidden if you see it like this, right? It is completely hidden. So how do we draw it? We draw it like this. The angle is theta. So this is hydrogen, this is hydrogen, this is hydrogen. These are back hydrogen. So this is eclipsed structure. Eclipsed structure. This one is staggered. Staggered means when the angle will become then when the angle will become theta here. So let me just show you how it will look like. It will look like this. Okay, it will look like this. If I wish I could make my hands invisible, but I can't do that, right? So can you see these three are front, and if I change it, if I change the color of these atoms that we have, you will see that how they actually looks like. Okay, can you see this? This is how it is actually looking like. This is how it is actually. From the front you can see back also, the back carbons also, the back hydrogens also, right? That is called staggered structure. That means everything is staggered here and there, right? That is called as staggered structure. Is that clear, everybody? Okay, these toys are very useful. Yes, right? So now here what you will have, staggered. Okay, staggered. Now I think things are more clear to you now, right? This is staggered, which is like away from each other. Theta is here 60, here theta is going to be 0, right? This is eclipse, that means hidden. Now stability. Now tell me one thing, when the hydrogens that you have, when they are at 0 angle, they will show more repulsions with each other because the angle is less, right? Repulsions will be more here, right? So if you see this here, when they are at the same angle, repulsions will be more, So because of more repulsions, eclipsed structure will be unstable as compared to staggered structure, which will be more stable, right? Because here hydrogen repulsions will be less here, right? So that's why staggered is more stable, and that's why we know that energy is inversely proportional to stability. That's why the energy of eclipsed is going to be more as compared to staggered, right? Okay. Now let's talk about conformers of propane. So in this case, instead of one hydrogen, you will have this methyl here. Let's say I am just drawing this methyl as this green atom as methyl. You can also see it like this, that okay, you draw, you have a carbon here, then you have another three hydrogens. Now I think this will be, this will get little complicated for you, right? That's why I usually show it by green as the methyl, but in reality methyl is this much. Can you see this is actually propane? This is actually how propane looks like, right? But if you see, I'll take these two as my main and this is my substituent, okay? Now, what things can happen, right? Either they can have the same angle means this is the same angle, right? In the same angle, they will be called as eclipsed, right? Where what you have, either you can say this eclipsed or you can say this as eclipsed, right? Eclipsed means more repulsions will be there. Can you see? Because now this group is bigger. Here earlier it was only one hydrogen here. Now here you have big methyl group, right? So even more repulsions you will see in the eclipsed. That is why a very important line is that eclipsed structure of propane is even more unstable as compared to eclipsed structure of ethane. Because here more repulsions are there. Energy of eclipsed structure of propane is higher because instability is more, because repulsions are more, right? And the staggered structure is when the angle is this much. I know now things will be difficult for you to, understand. But here, can you see there is 60-degree angle between this and this, right? So in this case, in the staggered case, the angle is 60-degree here, right? Okay. Then things are same, that stability order is staggered is more stable as compared to eclipse, because in eclipse the repulsions will be so high. Repulsions, can you see? This is a big group, so repulsions will be very high, right? And energy will always be opposite to the stability order, right? Now let's talk about conformers of butane, right? Now if I take this as my main chain, then I'll have to replace one more with butane. So what we can do, you can replace this also. Now even more repulsions, very high repulsions you will see, right? Very high. I'm just showing you this with the help of this diagram here. Does this conformer exist in real life, or it just, no, they exist. Rotation is there. Rotation is there. Okay, rotation is there. That's why we are specifically discussing about conformers of alkane, because of these rotations. Can you see so many rotations? If you see, there are too many rotations. This can rotate individually. This can rotate individually. These also can rotate, right? So many rotations, right? Can you see? If you see, at one point, I had just two hands. Here rotations will be more. So infinite number of conformers are there, because at one point so many rotations are possible, right? Okay, so many rotations are possible at one point. But if I draw it like little systematically, this will be my, if I say this is my main chain, then these are my methyl and methyl. This actually has four different conformers. Let's talk about that. One is when angle is 0 degree, when methyl and methyl, too many repulsions. Can you see? Repulsions, they are just opposite to each other. That's why this one is called fully eclipsed, where methyl is hiding another methyl. So it is fully eclipsed. Fully eclipsed. Fully eclipsed. Now if you see, fully eclipsed will be least stable here, right? Fully eclipsed will be least stable because methyl is repelling methyl. Can you see that these repulsions, already you can see it over here, right? Now next one is when theta is 60 degree. That means I'll rotate it. Okay, now I'm going to rotate the theta here. So theta I'll rotate like this, right? This will become, now if you see, repulsions will be less. Here repulsions were maximum, repulsions will be less in this case, right? This is staggered, this is also staggered, but they both have different name. This staggered because there are two staggered structures. One is this staggered where CH3 are next to each other. Then when CH3 are opposite to each other. That's why these two structures are called as, this is called as gauche and this is called as anti. This is called as anti, right? 60 degree angle, it is called as gauche. Now next is, gauche is also not so stable, right? Gauche is also not so stable. Now here after this, again you will have a eclipsed structure, but here this hydrogen is hiding this methyl. This methyl is hiding this hydrogen. Can you see? This methyl is hiding this hydrogen. This methyl is hidden by this hydrogen, right? Okay, can you see that, everybody? That is the reason here also repulsions will be there. Can you see repulsions are there, right? But the angle is 120 degree, because now this is 60 degree, one more 120. Then this will be 180 degree, where one more rotation is there you are doing. And this is, wait a minute, that was 0, this was 60, this was gauche, and this is how it looks like. Can you see, this is the anti-structure. Can you see repulsions are very less here, least repulsions, right? Repulsions are very less here in this case, right? So what we have done actually, earlier it was fully eclipsed, then it became gauche, then it became half eclipsed, then it became anti, right? And anti has least repulsions, and that is the reason anti will be maximum stable, and this is called half eclipsed, right? And that is the reason these things I have already told you, right, which is what. And in the end the stability order will be, anti will be maximum stability, then gauche, then partially eclipsed, then you will have fully eclipsed, From this stability order, they ask you a lot of questions, right? Okay. Right? Okay. Now, let's talk about, ma'am, why aren't you taking it as straight line? Which one as straight line? Because they are not in straight line. It's a tetrahedral. Have you forgot about chemical bonding? 4 bonds when you have sp3 hybridized is tetrahedral. It's 107 degree angle. Sorry, 109 degree angle. You can't take it as straight line. Okay. So now let's talk about Gauss effect. In Gauss effect, Gauss will become more stable. Gauss will become more stable as compared to anti. Now, ma'am, when Gauss will become more stable as compared to anti? Gauss will become more stable as compared to anti whenever you see hydrogen bonding here. So, like this structure you have, when you draw the Gauss and anti structure, in the Gauss structure you will see hydrogen bonding here. And that is why here stability of Gauss will be more. And based on Gauss effect, they ask you the questions. Let's see this here. Which one will show Gauss effect? Now for Gauss effect, there should be hydrogen, intramolecular hydrogen bonding should be there. Which hydrogen bonding? Intramolecular hydrogen bonding should be there. Intramolecular hydrogen bonding should be there, right? So let's talk about this. If you see this, here I think the structure is already drawn here or not? No. Okay. So I'll just show you that. If you see this, in this case, you will have OH here, and in the Gauss only, you will have CH3 here. So definitely no hydrogen bonding, right? In this case, you will have OH and you will have fluorine here. So definitely it will show hydrogen bonding. So Gauss effect will be applied. In this case, you will have OCH3 and OCH3. Here also you have OCH3. Here also you have OCH3. Now for hydrogen bonding, you need a hydrogen which is connected to the electronegative element, right? But here you have oxygen, but you have no hydrogen which is connected to the electronegative atom. That is the reason this is not going to show hydrogen bonding, hence no Gauss effect will be shown here, right? Okay, talking about these two things, which one will show? Here nitrogen and oxygen, they will show hydrogen, nitrogen, oxygen, I am saying nitrogen and hydrogen will show hydrogen bonding. So here Gauss will be more stable as compared to anti, right? In this case, this hydrogen can show, because this hydrogen is connected to an electronegative atom, right? That is nitrogen. And here you have another electronegative atom. So here it will show hydrogen bond, right? Again, Gauss will be more stable as compared to anti here as well, because in both the cases, it shows Gauss effect, right? Okay. Yes. Now the last part is conformers of cyclohexane. Usually not so much detail is asked, so I'll just tell you a conclusion part of this. So basically in the cyclohexane you have 4 conformers, right? The most famous and most stable conformer is chair conformer. Most stable and most famous conformer is chair conformer, right? So now in the chair conformers, right, what you will have equatorial and axial hydrogen, right? This is just usually very less questions are asked here, but still I'll mark it that which is equatorial, which is axial, right? This one is with blue that I'm marking is axial. These are axial, which are like up and down, right? This is down, this is up. Up and down are axial, right? Here also you will see this one, this one, this one, this one, right? Then this one, then this one. These are axial, right? If you talk about equatorial, they will be this one. 1, 2, these are equatorial, right? These are equatorial, right? When we will discuss hydrocarbons, we'll discuss more about this, right? These are equatorial, right? Okay, these are the equatorial and axial hydrogens, right? Okay. Yes, in the test series you can attend the test according to your time. These are mock. Mock test is when you have a proper time, but for the test series you can attend it any time, right? Okay, according to your own schedule you can do that. Now if you see 4 conformers we have, first is chair conformer, that is actually a staggered conformer where front and back carbon are away from each other. So chair conformer is staggered, okay. Then if you talk about next boat conformer, in boat conformer it is eclipsed when both the carbon, this and this carbon is hiding each other. These 2 carbon are hiding each other, these 2 carbon are hiding each other. If you see here, this front and this back carbon are not hiding, this front and this back carbon are not hiding, these 2 carbon are not hiding, right? So it is the first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon, all are staggered, right? But in this case, you will see front carbon, back carbon, they are hiding, that's why they are overlapping with each other. These hydrogen are, that's why overlapping. And here also they are overlapping, so they are eclipsed. So chair is staggered, boat is eclipsed, right? That's why chair is most stable. Then another is twisted boat conformer, and then you have half chair conformer, like a sofa you have, right? Like a chair you have, right? Like a chair you sit, this is just like a chair, like half chair. See, in full chair what you have, a proper like a chair to like relax, chill, like you find these kind of chairs on Goa beach, right? You will see these kind of chairs on the beaches, right? And these kind of chairs is what you will find in your house, right? Simple chairs, right? So these are simple half chair, right? Now talking about the stability here, right? Because chair is staggered, so that's why it is most stable. Boat is eclipsed, that's why it is least stable. This is eclipsed. Out of that also, half chair will be the least stable because of the more repulsions here, right? So chair, twisted boat and half chair is your the stability order of these, and directly the stability order is asked to you, okay? Directly the stability order is asked to you. Now this kind of question also they can ask you that this is the diagram, define which is A, which is B, which is C, which is D, like which is chair, which is half chair, all these things. So we know that the one which has maximum stability will have lowest energy. So A is going to be your chair, right? A is going to be chair conformer, right? Now if you talk about B, maximum energy means least stability. Least stability is for half chair conformer, right? Then between C and D, D is after B, which is less stable, that is twisted boat, and then last one is your boat conformer, that is this one, right? This is C and that will be D according to the stability order. We can easily write it. Now let's see 2-3 questions based on chair conformer, boat conformer, and let's end the session then. Okay, let's see that. Let's do that. So everyone, if you see, arrange the following conformation isomers according to N-butane. So what is discussed here? This is anti CH3, CH3 opposite. CH3, CH3 are like, this is not an angle, angle will be shown like this, like here they have shown the angle. If it is like this, that means it is overlapping, right? So that means this is eclipsed, and that too fully eclipsed. This is a gauche, there is no gauche effect applied here. This is, wait a minute, yes, This is eclipsed only, but this is half eclipsed. Half eclipsed. Because methyl is not hiding the methyl. Methyl is hiding hydrogen. Hydrogen is hiding methyl. Right? So that will be your gauche. That will be your half eclipsed. So maximum stability order is what you have to write. So stability order will be energy, potential energy. For that, firstly you have to define the stability order. Right? Okay. Opposite of that will be your answer. So in this case, firstly, maximum unstable is this one. So this will lie. Unstable means this will have the maximum energy. I am writing the energy order. It will have the maximum energy. Anti is most stable. So it will have the least energy. So 1 and 4 you need to find. 1 least and second maximum. 1 least and second maximum. Right? These two can be your answers. Now, out of third and fourth, which will have more stability? Gauche will have more stability. It will have less energy. So third will have less energy as compared to fourth. So answer will be D is the correct answer. Okay, based on the stability order, write the opposite, that is energy, and you will get your answer. Okay, yes everybody, 1, 3, 4, 2. Okay, it is anti-gauche, half eclipsed, then fully eclipsed. Okay, that is the stability order. If you write the stability order, that is anti. If you write the stability order, that will be anti, maximum stable, then gauche, then half eclipsed, then fully eclipsed. And the order of energy will be opposite to it. 1, 3, 4, 2. Okay? Right everybody? Okay. Which of the following conformation, this is 2008, this is a very old question but can be repeated, of cyclohexane is chiral. Chiral means it should have like plane of symmetry should not be present. Plane of symmetry should not be present. So what will happen, this is not any conformer, right? So chair conformer has POS. Boat also, if you see, has a very like beautiful POS, right? Wait a minute. Boat conformer also has POS. Chair conformer also has POS, right? Also has, wait a minute. This is like a Twitter sign. Okay. Chair conformer has center of symmetry. Wait a minute. Center of symmetry. Because in chair conformer, if I draw it here, if I write it here, in the chair conformer, where is chair conformer? Wait a minute. In the chair conformer, if you have center, you will go here and here, you will find same. You will go here and here, you will find same. You will go here and here, you will find same. So it has center of symmetry. It has center of symmetry. And boat conformer, if you see, boat conformer has plane of symmetry. That's why they are achiral. That's why chair conformer is achiral. This is also achiral, right? Chair conformer is also achiral. That's why this is also achiral, right? But when you talk about twisted boat, let me just show you the structure. When you talk about twisted boat, it has no symmetry. That's why it is going to be chiral. That's why it is going to be chiral. So answer is going to be, correct answer is twisted boat is the correct answer here, right? So answer is A is the correct answer for this one, right? Okay. Next we have increasing order of stability among the main conformations of these, which is 2-fluoroethanol. So firstly you will have to draw ethanol. This is 2-fluoro means here you have fluorine, here you have OH. Now guys, tell me, it will have hydrogen bonding. It will have hydrogen bonding. Can you see that? It will have hydrogen bonding. and that is the reason, because of this hydrogen bond, gauche effect will be applied here. So gauche will be more stable as compared to anti. Gauche will be more stable. So in increasing order, if you have to write, gauche will be maximum stable, then you will have anti, then you will have eclipse. These are increasing order. Can you see? This is increasing order. Eclipse, then anti, maximum stability is gauche. So answer will be C is the correct answer here. Okay, everybody, tell me. You wrote the opposite order. Gauche, they are asking increasing order. This is the increasing order. Okay, so answer will be C is the correct answer here. And that's it for today, guys. That's it for today. Today, see, very less attendance was there. So I'll see if tomorrow you guys are like there present, because today we have completed GOC. From next, I'm going to start and rearrangement of carbocation I'll do in between hydrocarbons only, right? From next, I'm going to start hydrocarbons, right? Next week, our target will be hydrocarbons. Okay? So, for next week, what is your duty? What is your duty? To revise GOC, right? And tomorrow, I am going to take up a lecture on the questions of GOC. Okay? The questions of GOC I'm going to teach, and I'll see, like GOC means IUPAC naming isomerism, then these electron displacement effect, tautomerism, right? All these things we are going to see questions on. And let's see how many of you attend this class and how many of you are able to do the questions, because some really important questions I'm picking up and we are going to do that, right? Okay, yes everybody? Okay, don't forget resonance. Okay, do spam it in the comment section, right? Okay then guys, I'll see you all in the next class. Till then, bye-bye. And before that, don't forget to register yourself to MVSAT scholarship program, which is 4th, 5th, 11th and 12th of October it is going to happen. And here you will get like 100% scholarship, 150 crore worth of scholarship and 2 crore worth of prizes and rewards, right? So what you need to do, just register yourself for totally free of cost it is, and then give this test, right? And get yourself here, which I am sure if you are attending my lecture, you will be here, right? Okay, yes. Okay then guys, bye bye, take care, see you all in the next class, bye bye. Wait a minute, let me see. Yes, okay. Okay then guys, bye bye bye.